Hello
Alex.
and welcome everybody. Hi Michael, how's it going?
Yeah, it's
How are you
good.
doing?
It's warm.
It's warm, yeah,
Heat.
yeah.
The heat
Heat
is
wave,
back.
yeah. Heat wave part, I don't know, 5. So yeah. Hi
Yeah,
Michael.
it's just
Well,
ongoing.
it's ongoing. It's a constant now. Yeah. Well, good morning, good afternoon, good evening, everybody, and thank you for joining. This is our Monday edition of Discovering AuraDB Free with Michael and myself. So looking forward to this session. We we can. I guess we can dive right in.
Yep.
Anything else to share?
Good
Private matter.
question. No, so I cycled to a lake on the weekend, so that was nice. Kind of going cycling, then swimming, then cycling back and having some ice cream.
Oh,
That was good.
sounds pretty
And
good.
I went down history lane with my dad. Actually went to the place where his grandma lived and where he spent
Oh.
his summer vacations when he was like 4 or 5 or 6 or so. That was
Oh,
like,
that's nice.
I don't know, 60 years ago or 70
Yeah,
years ago,
yeah.
as such. So that was an interesting trip
Hmm.
back
Yeah.
but it was good. Good time. Yeah, otherwise, no, I think Node CFP is still open. That's definitely something we want to mention. Perfect.
Yes.
Perfect segue.
Exactly. Exactly.
Thank you.
Perfect segue. As if we planned this.
Yeah,
Um,
and we haven't.
so we have not. So notes call for papers is still open, like you said. So if you are uh, interested in presenting and speaking on a Neo4j related topic to a global audience, please go to neo4j.com/notes 2022, and there you find the link to the call for paper, some more information about the
Yep.
event, and also some links to previous events if you want to watch some older content. But it's fun, it's engaging, it's don't worry if you think your content is not right, just submit. um, it's most likely perfect.
Yeah, exactly.
So
And we can also work with folks, or if you
yeah,
have questions, feel also free to reach out
yeah,
to us on the stream or on Twitter or on Discord.
yeah, we
If you
have
have questions around your content, then there's a Graph Connect channel, I think, or sorry,
there's a notes
a
channel
notes
on the
channel on Discord.
on Discord. There's a notes channel, but there is also a specific notes channel on the community forums.
Ah, cool.
So if you go to community.neo4j.com, there's an open. Let me quickly find that. And here we
Hmm.
go. This is it. This is the community page, and there is a specific thread and some links. So if you go there, our colleague Yolande has written a bit of a guidelines blog post. And the whole team is open and checking out. So if you are thinking, oh, I'm not so sure if this is right, just outline your ideas here,
Yep.
and we can give you feedback. So
Yep.
yeah.
Yeah, that's true. By the way, Alex, that reminds me, should you and I do another one of the live streams during Notes, like an Discover RDB free
Uh,
lightning
yes,
talk thing? So I think that would be fun in that
we should.
week. So we don't do the regular one, but instead we do an special edition or something like that, or perhaps both. Let's see.
We should. Yeah, we
But
definitely do a special edition. Yes. Yeah.
cool.
I wanted to do a couple of things for notes. We'll see if we what we can do
Yep.
beforehand, but also a few other things during or
Super.
afterwards. So that's
Yeah,
should be
can't
fun.
wait. It's not so long until
No,
Notes,
it's
right?
it's
So
closer than
only,
we think. So
yeah,
and Call for Papers ends already on the 20th of August. So that's another
12 days.
week and a half.
Yeah.
So
Yeah.
yeah, would be great to hear from you all.
Yes.
The weekly challenges. So yes, I put that in. We have weekly challenges on our community channel as well. So if you go to the community forums and check out the weekly challenges tab, then you can find it there, and you can have a try at these challenges. There are a couple. It's I think it's on summer break for now, but there are a couple back from from a few weeks ago. So if you are wanting some kind of challenge, and maybe you already did a Neo4j certification or did a couple of Graph Academy courses, then these could be fun distractions, quick. They're not too hard.
Yeah.
So you could, if you want a little bit of a puzzle, Neo4j puzzle game, then that's an option.
Yeah, that's a good point.
For today's topic, though, discovering Neo4j AuraDB free with Michael and myself, I just want to quickly give a recap of what Neo4j AuraDB is. So if you watch this for the first time, then we are going to pick a data set and check out that data set and look at it. If you have a data set that you think is interesting, we should have a look at it. You found this on Kaggle, or you have this data yourself, or some other means. Please share it with us. We can have a look. Generally, we look at the data set, we think about a couple of questions, we determine a data model, we load in query, and go from there. So it's fairly straightforward. If you're wondering what Neo4j AuraDB free is, then that's a free edition of Neo4j AuraDB. So if you go to that landing page right there, and I posted in chat also, you get a free edition of our database as a service, which we have launched basically almost a year ago now. So it's I think probably everybody knows.
Yeah.
It's free forever, so that's the big difference between anything you might have heard or seen before. So you basically register yourself with your email address and set up a password and an account, and you have a free database you can work with, and that has basically no limitations except for size of or amount of nodes and relationships, and that number has been increased recently. So you have 200,000 nodes and 400,000 relationships. So I think for any test, any database you would like to check out with graphs, anything as a test run, this is plenty. You get Neo4j Bloom, obviously, which is our visualization tool and the browser and the data importer. So all these features to make your journey as easy and as quickly as possible. So if you want to, you can now, with the data importer, go from a existing CSV file into a graph visualization without typing a single line of code. So that's pretty powerful.
Yeah, very much so.
Yeah. And it's free forever. And link will be in chat in a second. And today's database is on transportation. It's the London Underground.
Yep, London Tube. Exactly. So I thought, with people traveling for vacation and going to London and having fun there, and we can revisit that. I think if you've watched the Graph Connect keynotes, so Jim also had a section on the London Tube as well. So we should definitely have a look at that and check that out as well. So actually, we should be able, if you go to graphconnect.com, we should find Jim's, let's see, Jim's keynote here.
Yeah.
And somewhere at the beginning, he had the tube in there. So if you check out the keynote, then you should see his tube examples. This is ASCII, and somewhere there's London Tube as well. I don't exactly remember where it was, but I think you'll find it. So kind of going back to that, so I thought we look at the London Tube map, which is interesting in itself, and we can also discuss the modeling choices here and see how far we can get with data importer as well.
That's good. Yep.
And if you don't remember what the tube looks like, if you go to Transport for London, you find a lot of stuff there, including maps. And a lot of suspensions, delays, and things like that. So they always have something going on, either strike or suspensions or repairs or works or delays or other things. So the London Tube is always a lot of fun. And then they have lots of different maps as well that you can download or print or whatever. And the standard tube map looks like this, if you don't remember. So that's kind of the center of London with the River Thames and then the different lines here as well. So you have the Bakerloo line, Central line, Circle District, Hammersmith, Jubilee, and so on, Victoria line. And the Elizabeth line is the new one. That's, I think, not even in our data. And then all the stations are also on the back of the tube map. So you see it's actually quite a lot of stations. So 200 something or so, 270 or so. So we'll import those as well. And then we can see what we can do with the data, perhaps do a little bit of routing, visualize it in Bloom, and perhaps pull up a Neo-Dash for geospatial visualization as well.
And I mean,
so let's see how far we get.
If you look at that data and ever wonder what data storage would be good for this data, then a graph is I mean, it is a graph. Storing it as a graph and using a graph database for that is it makes a lot of sense. Then you might say, okay, London Tube Map is not so huge, so it could be done in a relational dataset. Yes, of course it can be done because it's just one city. But imagine if you go outside of one city, or you connect with other services, you go, you have so many more opportunities. So it's a real, evidently the better way to do it.
Yeah, exactly. So especially if you go to like multimodal transport and you combine tube with rail or car or bike or walking or whatever, right? So I mean, that's kind of just one tiny slice. Or even the bus routes. You might have a look at the bus routes as well. So there are like already a gazillion bus routes in London as well, right? And the tube is only like the tip of the iceberg, and then there's much more in there as well. Or like in Berlin, you have not just tube, you also have streetcars and buses and local trains, and like you have 6 different ways of public transport getting around in Berlin, for instance, right? So that's definitely already multimodal transport, but it's easy to understand, and it's a good intro data set. I thought that would be nice.
Yep.
And one of our colleagues, actually, who works on the Bloom team, had already prepared something, so we can use his data. We don't need to go and scrape data from somewhere, but we can actually take his data. But even if you find the tube data somewhere, it's mostly likely something like a list of stations, and if possible with geocoordinates, and then a list of lines, and then basically the stops on the line or the stations. Basically, that's what you usually would find there.
Yeah.
And which we should also see here. So before we go into that, let's create our Aura database so it can spin up in the background. So I just chose AuraDB free. I call the database London Tube. Pick Belgium as a region. Something that's new actually this week is we got a few more data sets. So I did put in some work last week, and we now have Stack Overflow data, which is basically, we had it on the stream already, like questions, answers, tags, users on Stack Overflow data, also with means to load your own data in addition to that. So which is really nice. And we have also graph-based recommendations, which is the movie lens recommendation dataset enriched with the MovieDB data, so which is also used in Graph Academy. So we are moving towards using more and more of Aura, and when Aura gets its provisioning API, then we can also switch Graph Academy over to using Aura instead of Sandbox, so you get it forever, your dataset. Cool. But today we picked a blank database as such, and click on Create. And then we can download our credentials, which is really useful. So I just call it tube credentials. Confirm that I got them, and then I don't have to remember to store it somewhere. It's just in the file as such. So while this is being set up, let's look at the data a little bit. So there's this repository here. I'll send it to Alex as well, so you can share it in this stream. 1 second. And then we can look at the data. So it's actually in Rust importer. So it's an importer written in Rust that loads the data and imports it into Neo4j, bus routes and tube routes. So if you're into learning a little bit of Rust, you can have a look at this. So it declares a bunch of structs for the different pieces, and then connects to Neo4j and runs surface statements to import them into Neo4j. So it's some params, and it uses a driver, Neo4j RS driver, that I still want to put on the Neo4j Rust page so that people can use it and see it there. Actually, I started to do a little bit of Rust over the holidays, so that was fun. And hopefully, I get to a graph layouts, graph visualizations as part of that endeavor. So wish me luck. So I did a particle system and I did a little bit of Game of Life so far, but I want to do a little bit more. So so that's kind of the Rust code if you're interested in Rust. So that could be a nice one to look at because it's pretty straightforward. But what we want to look at is the data sets. So we won't look at the bus routes immediately. So there's bus routes and stops, which is also bus routes. But what we can look at is London stations and London tube lines. And then there's a little bit more detail on these. So if you look at London lines, that's just the 13 lines minus the Elizabeth line, but you see basically just the name of the line, number, and color. So we might use this in Bloom, for instance, to visualize our lines, but we probably don't need this for importing it. But then we have the stations, which is more interesting. So we have for each station a name, X and Y coordinates for the screen, so which we probably won't use, latitude, longitude, which zone they're in. So if you remember our tube map, they have like zones 1, 2, 3, 4, 5, 6, 7, 8. It goes all the way 8 and 9 here. It's even zone number 9. So that's the zone. Then we have the postcode as well for the station. Right? So that's pretty straightforward. We just map them to a node and then we're good to go. Right. So something that we might want to do later on, we might want to pull out the zones as an extra node or turn this into an array or something like this as such.
Yeah, the model is not too complicated, but that
exactly. The model is actually pretty simple, but what's interesting is what you do with it. And then London tube lines is our a little bit more detailed. So that's the line itself, and from station and to station. So that's kind of the parts of the line basically, and so which gives us basically each piece or each segment of a line that we can use. But there's a similar file with a little bit more detail, and I wanted to try if we can load this file actually, which as well has the line, the ordering within in the line, which is also important, right? So what's the first station, or what's the first segment in the line, the second segment in the line, and so on. And then here are some passenger numbers, basically how many total passengers, peak, evening, and late passengers are on this piece of the line, basically, so kind of tracking people. And if we import this, then we could use Bloom basically to
the size of the
visualize it as width of the lines, for instance, so we see how frequent they are. Right. So that's something that we can do, and it's totally like 2,500 or something like that segments that we have to, or no, 970 segments that we can import here. Right. So that's basically data that we can look at as such. So there's a little bit of a slight hiccup that we might run into, or that we will run into, that we discuss as part of the data modeling. Okay, but our database is now running, and now we can use data importer. So we just need to fetch the password from where I downloaded it. 1 second. Downloads, tube credentials, password. Here it is. Connect. So, and then we add our files. So what I already said is we have the stations, right? And we could start with the tube lines, but we can also, perhaps we just start with the tube lines, which is a kind of a pretty straightforward one. So I'll just add these two files here, and then add our node for our station. And then we have two options. So first of all, we can map the data to the station, which is straightforward because we can use London station CSV, select the attributes from the file. We don't need the X and Y coordinates on screen, but latitude and longitude, which we can turn into a point location. We have this zone and postcode as well. Right?
Yep.
Okay, and our ID is our station name, which is also used in the other files. So you see that the surrounding circle around our station turned from a dashed line into a solid line, so it's now fully mapped, which is good. And then we have two options. Either we pull out a node and put it back so that we get a self relationship from station to station, That's
Okay.
one option.
Mhm.
And we could call this, for instance, connection here. And select tube lines as a file, and then say from station to station, and add the property, the tube line as a property here.
Yeah.
So that's one option. The other option is we just to visualize it nicer, we could also say we have a second station here, which is also just a placeholder. We take our stations and just take the station name. We don't need the rest of the stuff. And then we could also put in connection here on between the two as well, and then map from to and line, right? So that's two options. Either works. So the second one is a little bit easier to view and see. The first one is more efficient in import as such. So it's just something I wanted to show, just in case you have a more complex model, then you can also duplicate a node and reuse it in two places as well.
Just
So, but
for you to understand better, I guess this
exactly
is
for
more,
communication and
and
exactly.
yeah.
Right.
Yeah.
So, but otherwise, we mapped all our stuff. We probably can rename our field here from tube line into line or something like that.
Would you say it
And
doesn't make sense because this is not enough to make a case for making the lines specific nodes? Because
yeah,
it's
so
just
that's
10 or so.
yeah. So we could pull out the lines as a specific node, but then we in terms of modeling, so you could connect the line to all the stations that are on the line, but you can't connect them to the connections basically. So from that perspective, it's so either you would create a second overlay, which each station has like a mirror that's part of like a trip or on a line. For getting started, I thought we start with this, that we
No,
just have a
absolutely.
station
Yeah.
and the lines. Right?
Yeah.
Okay, and so if we import this, we'll see, so we can just click on run import and it will import the data. It's not a lot of data and it's pretty quick. So it takes 1 second. It creates 651 station nodes and 877 connection nodes, which is actually the drawback. So because currently the data importer only looks at the connection relationship type to create one or more connections. So if you have the same pair of stations appearing twice, it would only create one relationship as such. Right?
Okay.
So that means if we now open Neo4j browser here and pasting in our password, we should see between two stations. Let me put in line here as an attribute, so we see which line it is. Right? Then we see that some of them might not be going through all the way because they have been overwritten by something else. Actually, what we can do is we can do a query for this, which says we find connections, right, from a start station to the all the way to an end, basically. And where actually, let me do a simple version of this, which is basically this here. So we have a start station, something in between R2 and an end station. And we want to return these pairs of connections where the incoming connection to a station is of a certain line and the outgoing connection of a station is of this line. So where R dot line is equal to R dot 2 dot line, right? So the Baker loop goes into our station X, like middle station, right? And Baker loop also goes out of the station in the middle, right? So, and if we do this, we should see that some of these actually are disconnected. Let's see if you can see this. So this is probably Tramlink What is this DLR? So for instance, DLR has many more station stops than 2, but it's only partially there, right? So it doesn't continue as DLR, but as something else, right? So if you actually limit this to only DLR and r.y equals DLR, which is the Dockland light rail, and if we only show the data that we return. So if you get too much data back from Neo4j, it tries to be too helpful. So you see, for instance, here we see Elizabeth line and a bunch of others. So, or Jubilee. But if you disable connect result nodes, it will only show the data that you actually asked for. And here we see now in our DLR screen that there are some disconnected pieces here, right? So that are not connected to the other stations. And that's where another station basically overrode the line that connected here the DLR stations, right? So that's something that's currently a shortcoming of Data Importer that we'll need to address, because you try to in Data Importer make it easy enough that relationships are organized by type and direction and not necessarily by attributes in a relationship, because then we would have to add, what's the ID property of the relationship. For instance, in our case, it would be line. Because if I have 7 or 8 relationship properties, you don't want them all be ID properties. You only want to have one or so as ID properties that identifies the connection. Right. So from that perspective, Data Import is not so helpful here for us. There's 2 ways of how we can address this. So one is in Data Import itself, we could add. So what I did here on my computer is basically. Here's this. 1 second. Here. What I did, I filtered out basically certain lines from the overall file and wrote them to separate files here, right? And
okay.
So that's what we can do in Data Importer, where we basically then where we can import all these lines files basically. Or let me just import like 3 of them or so, because otherwise it gets too tedious. Just to show you the idea behind it. So we could import like Jubilee, Bakerloo, and Piccadilly, and what we then would do is basically drag out more relationships. So we should say, okay, we have now here the Bakerloo line, where we use Bakerloo CSV from station to station. And here you see I actually use the file with the additional information like order, total, peaks, and evening and late. And then we can turn the order into an int, the peak numbers into floating points because they're like averages. Sorry. So this would be like the totally, yeah, exactly. So actually, for one of the next versions of Data Importer, we actually want to integrate this a little bit better so that you can basically sub-filter within a file. So you don't need to create these files outside, but you can, within Data Importer, you can actually sub-filter these, right? So, and then I would do the second one, which is Jubilee. And here you see, it would be actually nicer to have the 2 stations side by side, basically, where you
it makes it a little bit
drag
clearer.
them over, right? So you see that it becomes a little bit flowery from station to station. Add the properties, select all except from and to, and then we again turn order into int, total into float, and so on, right? And let me just finish this one, and then we'll import it so you see the other lines. And which also has another advantage. So if I now run the import here, it also imported the Bakerloo Jubilee lines and so on. So if I look at my data in Neo4j here again, I now have a relationship type for the line, which is actually quite nice because then we can visualize this also with colors and so basically almost can build a tube map as such, right? So
why did it create a new connection there? It didn't override the existing one?
no, because I used a different relationship type in data importer. I had here, this one is called connection.
Yeah. Okay.
And this one is called Bakerloo and Jubilee. So you can have, actually in a graph, you can have multiple data models also overlaying each other, right? So that's more like like the Bakerloo line is more like a specific version. Actually, if I remove the limit, it should show us the whole line here, right? Why didn't it show us the whole line here? Something is missing. That's really weird. I'm not sure why it's not. This is overground. So these should be also connected. So this should not be not connected. So need to look at the data why these are not connected. But in general, you can have multiple overlaying graphs in the same database. So for instance, the connection view could be seen as an aggregated view, basically that has, if I switch this back to type, that has like aggregated connection information, and then it could be a detailed one which has the actual line information here. Right?
Yeah. Okay.
But I don't know why it didn't connect them actually, which is kind of a little bit weird. And so also for Jubilee line, so we need to look at the data why they are not connected. So they should be actually connected. So that's one way of doing it. The other way is loading these lines manually. So for instance, what we could use instead is just load CSV and do it ourselves. So that's what we're going to do next, is basically we just remove the relationships from the graph here and delete them, delete R. So we now have just the stations in there, and we can just basically grab this file here and import it. Actually, let me grab this file, which has the more detail. That's probably nicer to import.
Yeah.
So what we can do now is load CSV with headers from this URL as row return count star, just to see if it works. Yes, 864 rows. And then we can basically take this data and, for instance, return row limit 5, and then we see these are like our line from station to station and the peaks and the orders and so on. So something that you might see here is the comma, so actually 1000 separators, so we'll need to probably remove them. And yeah, but otherwise what we want to do is basically for these rows, we want to find our start node or our from node, which is a station where this station is row dot from station, and then the same for 2 is 2 station. So this would be what we basically get for each of these entries, right? So we found our row, our from, and our to station. You can also see this, look at this as a graph as well. And then we just connect them, right? But the problem is, so here again, we have two options where we can say either we need to pre-filter this and say, okay, we do each station as a pass. So we could say where row dot line is Bakerloo, and then we would say merge from Bakerloo to. That could be one thing, and then we set the properties, right?
Yeah.
Set rel dot, what do we have? Ordering order equals to integer row dot order, and then set rel dot total is to float row dot total, and we have to replace the comma with nothing, and do the same for peak and evening. No, what's it called? PM peak, right?
PM. Yeah.
Row dot PM peak. Actually, PM peak is the only one with in space, so we just call this peak probably, or PM peak.
Yeah.
Sorry. Doesn't really matter. And then the other one was evening. Evening. Right, so this would basically be one option, so that we create these and filter them basically, where we have to do more work. The other option would be instead of merging, so we could also keep our connections that we had at the beginning, right? But instead of merging just on the relationship type, we would also merge on the line as well. And I think that's probably something that makes most sense, where we put in a row.line here as an attribute on a relationship. And then it basically creates connection relationships, but has the lines in the relationship as well.
Yeah.
Right?
Yeah.
So evening, and what was the late was this third one, right? Late.
Cannot see it anymore, but no, I think we.
Late is here.
Late is up there. Yeah.
Okay, we have our order, our total, and so on. So now it created 614 relationships, so back and forth, and we have our connections now. That should also pass or span multiple lines basically as well. Right, so between two stations. Actually, that's a good question. So we could actually, for instance, find stations that have a lot of lines between them. So like some of the central ones that have like a lot of parallel lines going here, right, in our cube map. So like here in between Baker Street and or here in this green area, or here are 3 parallel lines or so. So that's actually a good query that we can start running already, right? So we would say,
it's not so crazy in London with the overlap, I think, but in other
Berlin
cities,
it's more, I think, right?
It's more, So
station. So we have our 2 stations, start and or source and target, and then we return source relationship or collect r t comma count star. You can just aggregate them basically as well. So we get our relationships and the number of relationships, and then we can order this result by the number of relationships here. And then actually we don't need to have in width, we can just do it like this. Order by count descending limit, let's say 3, the top 3 pairs of stations, right? And if you do this, we see that South Kensington and Gloucester have 6, so 3 per direction. And then here is Aldgate and Hammersmith, which have 2. But that sounds a little bit little as such, right? So
maybe you need to increase the number.
Yeah, because these are all our pairs, right? So there should be more than these.
Well, you can.
Okay, I guess we need to look at the data again. So something seems to be.
You could say where it's more than 2.
Yeah, but you already have the back and forth, so you should have actually at least, 4, because you have Piccadilly in this one direction and Piccadilly in the other direction, and these ones only show. Oh, sorry. I should do it like this, so we get both here, right?
Okay.
But these are only 2 lines per direction, which is kind of unexpected. I mean, circle line is interesting, right? Because circle line goes in a circle, right? So it doesn't go back. It's like the Ringbahn in Berlin that goes also around. But there's actually a reverse one in Berlin. Okay. So the other thing that we can do is on our stations, we also had geo coordinates as well. So if you look at this, we have latitude and longitude as well. So we can actually create a coordinate from that. Set n dot location equals point of latitude is n dot latitude and longitude is n dot longitude. And we don't want to have the limit here because we want to do it for all stations. Oh, and to float. We forgot to turn them into floats actually in the data importer. To float. And so we match all stations and set the location to a point type, which consists of latitude and longitude from our data, and we need to convert these strings into, and then we can actually remove the old ones that we don't need anymore. Right, so we have now all our stations here with the location element. And then we can create an index on station coordinate. Create index on station coordinate. So now we have a spatial index. So we can, for instance, pick a station where we are at. For instance, imagine we are at Acton Town, where s dot is and return s. And now imagine we want to see the stations that are closest to our station where we currently are, right? Yeah. So that's where we could use the spatial index. So we find all the other stations. And then we would say, for instance, we return the other stations and the distance of our station's coordinates to this other station's coordinates as dist order by dist ascending limit 5. These are the 5 closest stations basically to ours.
Yeah.
Right? And order by dist. So we see these 5 stations. Oh, we did forget to exclude our own station from it. So we should.
Why do we get distance null?
Yes, that's a great question. So, but we called it coordinate, right? Oh no, we called it location. I misspelled it. So actually it's location, not coordinate. Okay, it's actually location. And then we probably need to also, it's a little bit embarrassing. So you see that the station itself has a distance of 0 and the other ones have like 790 meters. So it's all in meters, the distances. Yeah. And we probably need to create the index on location.
Now what would be funny is if there is another station that's closer by distance, but further away by actually getting there.
Yeah, so that's a good question. So unfortunately,
I don't think we can calculate this, but it could be that another station is closer by. You could walk there, but if you want to take the actual train, you have to go around because there is no direct connection between these 2 stations.
That's a good point. So that's something that we can actually do, I think. Let's do this step by step. So one thing that's a little bit sad about the dataset is that it doesn't have like travel distance in here between the stations, which is a little bit unfortunate. Right? Yeah. Because it's not always a straight line between 2 stations. So we can approximate this and say, if we want to find stations and their connections, we can actually compute the distance between the 2 as a straight line and put this as a distance relationship on the segment, right? Mm-hmm. So this gives us like the direct distance, but only if the stations are connected by something, right? So what we can now do is we have our from and to stations here, right, that are connected. And now we can basically set on the relationship a distance property, which is our distance between from dot location and to dot location, right? So this is not 100% correct, but it gives us a rough estimate of the distance as well, right? And then we probably want to turn this into a float. Oh no, it's probably already a float. Sure. And so we can do this, and it does it for all the distances. So we have now a distance relationship on our nodes here, right? On our relationships here. So it has now a distance of 1.4 kilometers as such, right? Yeah. Mm-hmm. So now we can actually do fun stuff like routing and getting from A to B, because now we don't just know how to get there, but also how far it is, basically in kilometers or in meters as such, right? So we can, if you want to look at routing a little bit, so we can pick two stations on our map. So for instance, if we take, let's zoom in a little bit. Let's say we want to go from Wembley Park to Aldgate or something like that, right? So how would we get there, right? So if you look at the map, we would go here to Baker Street probably, and then from Baker Street to Aldgate or so, right? So that would be one option. Another one would be going down here to Westminster and then up to Aldgate, and a bunch of other connections as well, right? So let's see if our data is actually good enough, because as I said before, there seems to be some gaps in the data, which is kind of a little bit weird. But what we can do now is we can find our start and end station. So similar like we did it before. So with history, we can look at our past statements here, and we had where we did the distances. Where was the distance one? Here. So we have our start station, which was, what did we say, Wembley?
Wembley Park.
Park, right? Yeah, Wembley Park and Aldgate, right? So our start station is Wembley Park, and our target station is Aldgate. And now we want to find the path between these two, and this is where basically shortest path comes into play. We want to have our shortest path between source, connection, target, right? Yeah. And return path should give us our shortest path, right? And the path is then either a single line or multiple lines as such, right? So, and I hope I didn't misspell anything. Yeah. Okay, no, it should be fine. And it didn't find anything, which is interesting. So which could be like now a data problem because of the data that we might not have. Or, yeah, that could be the only problem actually, right? So that I could imagine as such. So if you pick something else that's closer, I actually don't know why we have a data problem. If we, let me just see if we can re-import the connections. So this is our data here. Perhaps I'll take this other file which had only the connections directly.
Yeah, maybe that's not complete the other one.
Perhaps there's some statistics that are missing from some of the other ones, and then that's why it didn't have all the stations. So we just put in, we remove all these properties here and just connect them as such. Let's see if it added another. Was it not called line?
Yeah, maybe it was called different.
Tube line. Oh,
tube line. Yeah.
Here it was called line. Okay. Okay. Tube line is. Okay. So it created a bunch of more relationships here in our data.
Let's try the other query again.
Then we need to set the distance again on our.
We need, yeah, that's true.
Or we don't need it yet, but we need it later. Okay, we have our distance, and now we can try our shortest path again. And finally, we get one, actually.
Yeah, okay, nice, good.
And here you see that an unsmart routing thing would just switch between lines because they don't know that actually staying on the same line makes a lot of sense, right? So you would start at Wembley Park and then switch lines 4 times or so, right? So, what we could now say is actually give us all shortest paths, right? Which gives us all shortest paths, which gives us more than, no, exactly also 1. Okay, that's interesting. But now we have the problem that we can't, unfortunately, shortest path doesn't allow us to express predicates on the path that's kind of used inside of the expansion here, right? So we could do something like where, or for instance, return path order by something like the number of different lines. We want to minimize the number of different lines on our path, for instance, right? Or the number of crossovers, right? So, so that's something that we can't express easily with shortest path, unfortunately. So we could find all paths, but that's kind of a lot then, right? So we could say order by length of path descending or something like that, limit 5 or so. So this might probably take too long because it's should probably also limit.
No, it's it's going through the
getting all paths. Okay, so this is actually okay. This is okay. When we limit it to something, then it's okay. Otherwise, it would kind of create this gigantic set of potential paths, and then. So, but now we can actually, because now we can express stuff on this path, right? So now we can say actually with path, comma rel in relationships of path. We want to go get the line from this, right? And then we turn this into a set as lines, and then we want to have, for instance, we could say where size of lines must be less or equal to 3 or 2 or something like that, right? So then it would only find us things where it has only a few lines.
So that basically means
fewest lines.
Changing points, yeah.
And actually to be ascending, not descending, right? So it would here start at the metropolitan and go then switch over to circle line and then go all the way on circle line, for instance, right? So that's more realistic. So this is something that I would usually express probably as a user-defined procedure or function, kind of to minimize the number of paths, number of different lines, or you would have to add a switch over time, where you add the switch over time to the distance bit, basically, where you create a self relationship within the station, where you basically add basically switching from one station to another is basically yet another.
That's something that's not in our data, right?
In our data set.
Yeah, it might take a couple of minutes to get from one line to the other in the same station because it's
exactly right.
So
far apart. If you add this, then that would also be interesting. So the other thing that we could do is if you want to take in the distance into account. So this already works for us for our simple use case to compute them, right? So it should also be quick enough to compute them as such. So there usually you would probably model it really that it would not be connection, but you would be like the line name, and then you could minimize this across these as well. Or say you want to actually start at one line, have a second, and then at most a third, for instance. That could be also something that you do. So the other thing that we can do is, now that we have the distances on our relationships, here's our distance. We can also use something like Dijkstra. So in the epoch library, Dijkstra. I just realized we should have taken more time for all of this, so there's pretty a lot of stuff. So what you can do is basically in Dijkstra you would provide start node, end node, and then a name for the weight property, which is distance in our case, and then it returns the path basically based on that. So we can actually try this as well. So which would be basically similar to our simple all shortest path basically routing. We would say call epoch Dijkstra algo Dijkstra, and then start end relationships. Algo Dijkstra, and then our start, our end, our relationship is connection, and then in the config, or not, the distance is our distance parameter, and that's it, I think. Yeah. So, and then we should get basically return path. And this yields a path and a distance, I think, as such. Let's see, path and weight. Return path and weight. And this should use the data to compute the distances, basically. So the total distance is basically our 16-kilometer route. And this gives us the shortest one. There's also an A-star algorithm in Epoch, which is faster because it can also take into account the geolocation of the points. So it goes basically, it's like a snake which goes to a target or something like that, and then it basically gets closer and closer, but it knows also where the target is, and so A-star is a little bit better then, because you can also provide the latitude and longitude properties as well. Right. So, but this also doesn't give us yet the information on the on staying on the same line. So either we need to do it on a model, that kind of switching between lines at a station is actually another trip, basically, right? So that there's actually not a station as such, but at a station there's basically the exit of one line, like Baker Street, Metropolitan arrival, basically platform. It's actually the platform, actually, right? So that you would have to model.
It's the platform, yes.
And then the other platform, and then you have the distance between the platforms. So if you have the data, you could even take the distance into the graph model, and then should actually minimize it automatically based on that as well, right? So because if you don't have to switch lines, then your distance is 0, basically, right? If you stay on the same line. And if you do have to switch lines, then you get the foot traffic distance plus some wait time. You would probably also not just add the travel time, but you would also do the average wait time, basically. Half time of the frequency, basically. So if a train comes every 5 minutes or 10 minutes, then the average wait time would be 5 minutes or something like that, right? So, and then this would be added to the travel time, because you also have to wait for the new train to arrive, right?
Exactly.
And then this could be represented in the model. That could be actually something we do another time, basically look at modeling this with platforms and distances on platforms, but then we need to get the data for that somewhere as well. Cool. We don't have so much time anymore. Otherwise, I would have quickly shown Bloom on top of this data set.
But we can overrun a little bit. Let's
overrun a little bit, because I wanted to show the styling based on the attributes, which is usually quite nice.
Yeah.
So what we can do, especially on the relationships here, our connection, first of all, we can say our text should be rule-based, and we want to put line as a text on the connection, basically. So we don't want to show this, only this. And then we could color them also by line. So we could apply a color, basically also rule-based. tool-based, we use line also to color, and it's a range. Sorry, line, size, color, apply color, and it would use that. So it would color our nodes based on the line as well, our relationships. And the third one that we can do is we can use the distance, for instance, as width here as well, where we have a distance range and we apply the size. Sorry, the size, not the color. Between 0.25x and 4x, for instance, as such.
Yeah.
We might need to put in the ranges here. So we have the text information, we have the colors, and so if we now fetch our data, so we have station to station of connection, we should see so the different width of the based on distance. We could also do it on the other attributes, but Bloom didn't pull them in, so we need to see this. And actually, let me just go back to this one, which is color. There was actually...
I think you need to be by a select condition.
So I wanted to do color.
But now you...
And I actually want to apply the unique ranges.
Yeah, you need to, exactly. Isn't it here?
Oh, it's probably it only works for numbers and not for text. Interesting. So it could be a good, because if I use, for instance, something like order, then I can do...
yeah, you need to go into the drop-down here.
Something like... between. No, I didn't want to have between. I wanted to have order and then... Oh, no, that's only for nodes, it seems, that it can do unique colors. Ah, interesting. Interesting. Because in nodes, I can select unique colors based on an attribute.
Oh, okay. But we could... That would help as well, right? If we do the nodes instead of the...
But the nodes don't have the line information. They only have like something like postcode or something like that. You know what I mean?
Yeah, I know what you mean. Yes.
But what we can do is, for instance, here, instead of using the distance, we could use the size range for how many people travel on these segments, for instance, right? So you should now see actually bolder ones that have more travel.
As the busier stations, yeah.
Busier segments, basically, right?
Or segments.
For the station coloring, I think what we can do in nodes, here, if we pick one, let's say zone, for instance. Oh, zone is actually, see this, I was looking for this unique values, and that doesn't exist in relationships.
Yeah.
And then apply color, so we could see them by zone, basically.
Yeah.
Here, right?
Ah, okay. Yeah.
So you see probably the red ones are probably the inner zones, and then the further out you go, it's probably zone number 6, right? Yeah. And the red ones are probably zone number 1 or 2, see?
Yeah.
So it actually, the graph layout already layouted it as well in a way that it's put the central nodes more in the middle and have the border nodes around it, basically. So,
yeah.
Right. And the other thing that we would also do on the station styling would be we would put in the station name as well. Right, so when we zoom in, we would see the stations actually.
Yeah.
Right.
Same probably goes for the relationships.
Yeah, for the relationships, we should put in not connection, but line.
Yeah.
So now we have the lines here, right? But it would be nice to have the unique coloring for relationships also by attribute, right? So that's probably something that we can give the Bloom team as a feature request.
Yeah.
The unique values thing. I mean, yeah, that would be probably. Otherwise, if you had relationships that had like the line name as relationship type, then you could give them a unique colors basically based on the relationship type. That would work.
You can filter. I mean, if you click on the filter icon, you could say I only want to see Bakerloo
Yeah,
line.
so we could say
But
add
that's
connection and then line and then just Bakerloo, for instance, and then
yeah.
apply filter, and then dismiss filtered elements should only give us the lines,
The other lines go
that.
away. Yeah. Then we see the Bakerloo
Right.
line here. Yeah.
And here you see also how it comes from the outside, goes to the central stations, and then moves to the outside again to an
Yeah.
zone 2 or so, or 1 and 2.
Yeah.
Right. That's also interesting. So these zones would be another thing that we could model in this data set as well. So there's a lot of stuff that we haven't done and then we could do,
No,
and
yeah.
perhaps for one of the
And then
next
you
sessions
think
we could do.
it's a small data set and you can only do so much, and then
Yeah,
it's already
exactly. Right. And then we didn't even do spatial layoutings, right? So I also have like Neodash over here, so that's something else that we could do, like spatial layouts of the stations as well,
Yeah.
and do some charts and other things based on the graph data as well.
Maybe we
So
do a continuation of this next week.
yeah, that sounds like a good idea, and perhaps you can see if we find a platform data set where it's actually also the platform data and the walk lines and the travel times is available. I'll have a look if I
Yeah.
find a little bit more detailed data set on London Tube. Cool, sounds good. Happy to do that.
Cool. So it was very, very good, very interesting. Yeah, like I said, initially you might think that this is not as exciting, or maybe not as insightful, or not as rich.
Yeah,
But then all these questions we couldn't answer, and then more questions that just
yeah,
come from the data set, and it's all very graphy, all very
yeah,
very related connected data stuff. So it was very interesting, and I think a good showcase of what you can
yeah,
do. And yeah, don't think your data set is not powerful enough, or not doesn't give you insights, or is not exciting enough. It doesn't matter. I mean, if you have a data set you want to work with, you want to play around with, just use it and see, and you'll be surprised, I guess, how far you go, and what else comes up when you play around with it a little bit, and have that different viewpoint on your data.
exactly. And I just remembered actually at Graph Summit London earlier this year, the Transport for London also uses Neo4j actually. And so if you're interested what they're doing, so you can basically get the video recording of their talk, I think, as well. So that might be something that's also interesting for that.
Yeah.
And there's also a bunch of other folks. So if you just Google for Neo4j and London Tube or Transport for London, or so, there's also some other folks that already done imports of these kind of data sets.
I think this was
Rick did
recorded.
one.
I think it was recorded, but I don't know if the video page is up yet. So
Yeah. Or it will be up in a few days or
it
weeks.
will be up soon, exactly. But yeah.
Yeah. Cool.
All right. Okay. I think that's it for today. Thank you for your time. Thank you for the tour and for the demo. So it was very interesting. Thank you all for watching. I hope this was interesting for you as well, and you had learned something maybe, or at least had a joyful hour. So that's what it is all about. This week is a little bit more quiet, so this is the only session we are doing this week. But Michael will be back next Monday on Discover Aura. So again, maybe we continue doing exploring the Transport for London dataset, or we do something else. Until then, have a great week. Stay safe, and see you soon.
Take care, everyone.
Take care.
Bye-bye.
Bye.